Assalamualaikum everyone. Okay, we have done the techniques of integration for the improper rational function. Okay, and also for the proper rational function where the case gx cannot be factorized. Okay, so let's recall what we have done before this. Okay, we have in techniques of integration, if you have rational functions, you have to identify either it is an improper or proper rational function. Okay, if you have an improper rational function where the power of fx is greater than the power of gx or equals to the power of gx, then we will simplify by using long division. Okay, so the reason why we have to use long division is we want to change the improper rational function into the form of a proper rational function, this one. Okay, so next, after we have changed from the improper rational function to a proper rational function, we have to check whether your denominator can be factorized or cannot be factorized. Okay, if your denominator cannot be factorized, we will use completing the square. Okay, please remember the formula of the completing square is x squared plus bx plus c equals to x plus b over 2 square minus b over 2 square plus c. This is the formula for completing square. Okay, remember why we have to use the completing square? Yes, because we want to use the formula of integration that involve arctangent or the tangent inverse and sine inverse. The formula is given as the integration of 1 over a square plus x square dx equals to 1 over a tangent inverse x over a plus c. And another one, so this is the first one, and the second one is the integration of 1 over square root of a square minus x square dx equals to sine inverse x over a plus c. Okay, all right, so now we will continue with the next topic where you have the integration of a rational function with the form of proper rational function, and you have the case where your denominator gx can be factorized. Okay, if your denominator gx can be factorized, we will simplify by using partial fractions. Okay, now we have the case is proper rational functions where the gx can be factorized. Okay, so if we have this kind of case, okay, what we have to do is we have to simplify by using partial fractions. Okay, what is partial fractions? Okay, partial fractions is a fractions, okay, or a rational functions, okay, which can be written in the form of a sum of the simpler fraction. Okay, for example, let's say in numbers, let's say we have 7 over 12. Okay, for example, okay, number we have 7 over 12. Okay, in number 7 over 12, it can also be written as 1 over 3 plus 1 over 4, right? Okay, where if you rewrite, or if you write in the form of a fraction, you can multiply this one with 4, this one multiply by 4, and then this one multiply by 3, and then you will get, it will be 4 over 12 plus 3 over 12. And this is also what we call as the simpler fraction. Okay, that means from a fraction, okay, you can factor it and express it into the form of a sum of a simpler fraction. Okay, this one is the example in numbers. What happened in fraction? Sorry, what happened in function? Okay, so let's say in function, for example, let's say if we have 3x plus 5, okay, divide by x plus 1 times x plus 2. Okay, in a rational function, you can also express this rational function into a simpler fraction. Okay, which means if you simplify, for example, for this one, you will get, it is 2 over x plus 1 plus 1 over x plus 2. So this is what we call as the partial fractions. Okay, where we will express a rational functions into a simpler fraction. Okay, so your target here is we want to find this one, the numerator for each terms. Okay, we have three cases in partial fractions. The first one is gx is a product of distinct linear factors. The second case is gx is a product of repeated linear factors. And number 3, we have gx is a product of an irreducible quadratic factors. Okay, alright, for each case, we have a different method or different setup for the partial decompositions. Alright, so the first one is your partial decompositions. It will be in the form of fx over ax plus b times cx plus d will be equals to a over ax plus b over cx plus d. Okay, for case number 2, the partial decomposition will be fx over ax plus b to the power of n will be equals to a over ax plus b over ax plus b to the power of 2 plus ... until n over ax plus b to the power of n. So for case 2, it depends on the power. Okay, and for case 3, your partial decomposition will be fx divided by ax squared plus b cx squared plus dx plus e. It will be equals to ax plus b divided by ax squared plus b plus cx plus d divided by cx squared plus dx plus e. Okay, so later on we will see how we will simplify the rational functions into a partial fractions. Okay. Okay class, let's proceed with the first case where we have to solve the partial fraction when gx is a product of distinct linear factors. Okay, so this is the steps that we will use. Okay, the first one, we have to set up the partial decomposition. So this is the partial decomposition for the case where your gx is a product of distinct linear factors. Okay, so linear factors means here, this one you have a linear factor, this one you have a linear factor. So each bracket here we call it as the factor. Okay, alright, next we want to find the value of a and b. That means we want to find these two. Okay, so it depends on the questions. If you have more than two factors, that means we will have a, b and c. Okay, alright, and lastly we will solve the integral. Okay, let's continue with the example. Solve the following integration. So let's start with the first one. We want to integrate 3x plus 5 over x plus 1 x plus 2. Okay, in this example, we have a rational function. Okay, we have a rational function and it is a proper rational function, and your gx can be factorized. Right? Okay, how we know that the gx can be factorized? Because it is right in the form of factors. Okay, so if your gx can be factorized, you have to use partial fraction. Right? Okay, next. For partial fraction, we have three cases. The first one, distinct linear, repeated linear, and also the irreducible quadratic factors. So let's look at the factor. We have here x plus 1 is a linear factor and x plus 2 is also linear factor. That means it is in the first case, case 1. Alright, okay, next let's set up the partial decomposition. So set up the partial decomposition. Alright, okay, firstly we have 3x plus 5 over x plus 1 x plus 2. Okay, we will only set up the partial decomposition to the function without the integral sign. Okay, next continue. The partial decomposition will be a over x plus 1 plus b over x plus 1 x plus 2. Okay, so look at here, this one will be this one. Okay, the first term a over x plus 1, and the second term or the second factor for b over x plus 2. Okay, next step is, your next step is we want to write a over x plus 1 plus b over x plus 2 in one term or in one single fraction. Okay, that means we will have to equals your denominator. Write the equal denominator. Okay, so now let's continue. To write the equal denominator, you will have, here is a x plus 2 plus b x plus 1 over x plus 1 x plus 2. Okay, again. Okay, let's look at again. So we want to write the equal denominator. Make sure the denominator in the left hand side must be equals to the denominator in your right hand side. So you have here 3x plus 5 over x plus 1, x plus 2. Okay, your target is we want to write with the equal denominator as in your left hand side. So meaning here your denominator should be x plus 1, x plus 2. Right? So what will be your numerator? Okay, to write with the equal denominator, okay, for the first term, your denominator will be multiplied with x plus 2, right? And you have to multiply with x plus 2 in your numerator as well. Alright, and then for the second term, okay, to make it as the equal denominator, you have to multiply with x plus 1, as well as your numerator you should multiply with x plus 1. Okay, that's why now your numerator will be a times x plus 2 plus b times x plus 1. Okay, next you have your right hand side with the equal denominator. Okay, now you have the similar denominator in your left hand side and in your right hand side, right? Okay, so what you have to do now is you can cancel off your denominator, or in other words, if you bring your denominator to the right hand side, that means you can cancel off your denominator. So now we can cancel off the denominator, and the remaining functions we have here is 3x plus 5 equals to a x plus 2 plus b x plus 1. Right? Okay, remember your target is we want to find the value of a and b. Right? So now let's continue with the next step. Okay, next step, to find the value of a and b, we will use the suitable x to eliminate one of the factor in this function or in this equation. Okay, so what we have to do now, let's say for the first one, let's say we want to eliminate the factor from b. Okay, so what we can do is we can use we can substitute, okay, the value of x equals to -1. Okay, when you substitute your value of x is -1, you will get it is 3 times -1 plus 5 equals to a -1 plus 2 plus b -1 plus 1. Okay, so as what we can see here, -1 plus 1 here will be 0. That means we eliminate one of the factor, okay, in this equation, so that we can get the value of a. Alright, so next, when we simplify, you will get here is -3 plus 5 is 2 equals to, so -1 plus 2 is 1a, so a equals to 2. Alright, okay, with the similar concept, okay, you can find your b by eliminating the factor from a. Okay, that is, we can substitute, okay, we can substitute the suitable value. So in this case, if we want to eliminate x plus 2, so we can substitute x equals to -2. Right, so now you will get 3 times -2 plus 5 equals to a -2 plus 2 plus b -2 plus 1. Okay, and you will get, so -6 plus 5 is -1 equals to, and this one, now this factor will be 0. Okay, and you only have here is b, -2 plus 1 is -1, so it will be -b, and you will get the answer is b equals to 1. Okay, so now we have the value of a is 2 and the value of b is 1. Okay, next continue. Now your integration now will be, so the integration of 3x plus 5 over x plus 1 x plus 2 dx will be equals to the integration of, so you have here, it should be a over x plus 1 plus b over x plus 2, right? We have the integration of a over x plus 1, that is your a is 2 over x plus 1 plus 1 over x plus 2 dx. Okay, so this is your a and this is your b. Okay, and then now continue, you can integrate directly using the basic integration formula, that is we will get the answer is 2 ln x plus 1 plus ln x plus 2 plus c. So this is the final answer. Alright, okay, so again the step is you will start with the partial decomposition. Okay, and then you will find your a and b by substituting your x with the suitable value of x. Alright, and lastly we will solve the integrals. Okay class? Alright, okay, now let's see another example. Okay, for the partial fraction where you have the denominator is the distinct linear factors. Okay, so firstly we have here is the integration of 16x minus 8 over x squared minus 1 x plus 3 dx. Okay, firstly you have to identify the types of your function. So we have here, it is a rational function. Okay, and then your rational function is a proper rational function. Okay, that is your denominator, we have the highest power is x power 3. Okay, when you expand here it is x power 3, and for this one is x power 1. Okay, alright, and then continue next, identify your denominator. So in this case obviously the denominator can be factorized because it is written in the form of factors. Okay, so your gx can be factorized. Okay, next continue, identify whether your factorization is complete or not. Okay, now when you simplify, it will be the integration of 16x minus 8 over x plus 1 x minus 1 and x plus 3 dx. Okay, make sure your denominator is factorized completely. Alright, okay, next continue. Since you want to use the partial fraction, right? Okay, we want to use partial fraction for the case 1. Case 1. Okay, so starts with your partial decomposition. Okay, Your partial decomposition now will be 16x minus 8 over x plus 1, x minus 1, x plus 3, okay, will be equals to a over x plus 1 plus b over x minus 1 plus c over x plus 3. Okay, since we have 3 distinct linear factors, so meaning you will have 3 terms in your fraction, in your partial fraction. Okay, so now we want to find the value of a, b, and c. Okay, next step, we will write, the equals denominator in your left hand side and right hand side. Okay, write equals denominator. Okay, so now we will get, it is 16x minus 8 over x plus 1, x minus 1, x plus 3 will be equals to, so with the same denominator, here will be x plus 1, x minus 1, and x plus 3. Okay, now, so to make it the first term with the equals denominator here, so you have to multiply with x minus 1 and x plus 3. Right? So as well as your numerator, you have to multiply with x minus 1 and x plus 3. Okay, for the second term, you need to multiply with x plus 1, x plus 3, right? As well as your numerator, you will multiply with x plus 1, x plus 3. And the last term, you have to multiply with x plus 1, x minus 1. Okay, so this is the concept that you will use to write the equals denominator. Okay, so for now, your numerator will be a times x minus 1, x plus 3 plus b, x plus 1, x plus 3 plus c, x plus 1, x minus 1. Okay, class? Alright. So next, continue. You will cancel off your denominator. And you only have the remaining equation here is 16x minus 8 equals to a x minus 1, x plus 3 plus b, x plus 1, x plus 3 plus c, x plus 1, x minus 1. Okay, next step is we want to find the value of a, b, and c, okay, by substituting the suitable value of x, and we can eliminate one of the factors. Okay, one or two of the factors. Okay, let's look at here. Let's say we substitute. Okay, let's say we choose to eliminate the factor x plus 1, for example. Okay, so if you choose to eliminate the factor x plus 1, okay, we will substitute x equals to 1, right? 1 minus 1 will be equals to 0. So substitute now, you will have 6 times 1 minus 8 equals to a. So 1 times 1 will be 0, that means here will be 0. Okay, plus b, so this one 1 plus 1, 1 plus 3. Okay, but then we have here another x minus 1 here. Okay, that means you will have here is plus 0, right? So x minus 1 will be here, c times 0 will be 0. Okay, so the remaining equation here we have is 16 minus 8. It will be 8 equals to, so b 2 times 4. Alright, so you have here is 8b equals to 8. That means your b equals to 1. Okay, continue with the similar step. Okay, we want to substitute x equals to -3. Okay, for example, to eliminate the factor of x plus 3. Alright, okay, now we have 16 times -3 minus 8 equals to a. So this one, a will be 0, because here we have -3 plus 3 will be 0, right? Okay, okay, and then continue. You have here is 0, okay, plus, so this one is also 0. -3 plus 3 is 0, so you have 0. I just put 0, and then plus c, this one will be -3 plus 1, and -3 minus 1. Be careful with the bracket. Okay, so now you can simplify, and you will get your answer will be this one. Okay, your c is -7. Alright, continue with the next one. We want to find the value of so we have the value of b, we have the value of c, we want to find the value of a. So what is the other factor that we did not eliminate yet? So we have here it is for x plus 1 here. Okay, so to eliminate x plus 1, okay, we will substitute your x as -1. -1 plus 1 will be 0. Okay, now when you substitute your x as -1, you have 16 times -1 minus 8. And then you have your a times -1 minus 1, and -1 plus 3, and the rest will be plus 0 and 0. Okay, and next we will simplify, and we will get your answer for a is 6. Okay, so now let's solve the integration. Alright, and now we will have the integration of 16x minus 8 over, okay, so we have x plus 1, x minus 1, and x plus 3. X plus 1, x minus 1, and x plus 3 dx will be equals to the integration of 6 over x plus 1 plus, so where's your b? Your b is 1, plus 1 over x minus 1 minus 7 over x plus 3 dx. And when you simplify the integration, we will have 6 ln x plus 1 plus ln x minus 1 minus 7 ln x plus 3 plus c. So this is your final answer. Alright, okay, so please try another example by using the given steps in this video. Alright, thank you class.